Well, first of all, I want to make a test, see if you are still alive or you're already dead, because I haven't seen any participation for you. And there's two things that have been constantly repeating since the first panel. And I want to know if you just realize them. There are two main challenges that face the OEMs today. It's something that has been repeated in the first panel, second panel, and I have seen it in the third panel. Is anyone of you remember which one of those two main challenges has been mentioned repeatedly so far? Don't be shy. I know now that you're alive, so it's fine. One is sustainability, and the other one? High rates. That is true. That's the two main challenges that are facing the OEMs, but it's facing in all the supply chains already. Well, production rates basically is something that is related to three main factors. One is scalability, the other is repeatability, and the other one is just create systems that are robust. When you think about the three things, the main thing that comes to your mind is probably automation. Automation creates equipment, dedicated equipment to solve these issues. So if any manufacturing process aims to be incorporated in an industrial plant, needs to ensure that. So at the end, you need to create equipment to ensure that you are able to meet those high production rates. And at the same time, and as we have mentioned today, it's not only doing it by the sake of so, but they have to also overcome some challenges in the face of sustainability. I mean, energy consumption, probably one of the things that has to be optimized and has to be ensured the efficiency of the systems related to the other challenge that we are facing. For that reason, we are bringing this table on, because thermoplastics, in order to be applied to any industrial site, has to meet those requirements and be at the same level as today thermoset and all manufacturing are already in place. So we are bringing a panel that has experience in the manufacturing and providing automated turnkey solutions for the industry for over several years, mainly for manufacturing and composite parts. And also they are working heavily on developing equipment for being able to apply thermoplastic technologies at the same time, at the same level that thermosets. The first one is M. Torres. I bet most of you know the company. Is represented by Mr. Inigo Idarreta. He's head of R&D operations and special projects in M. Torres, which is a member of the team since 2011 and always involved in composite projects, related composite projects. Coriolis is the second company. It's represented by Mr. Miles Fariñas. He's a senior technical sales engineer, also part of the Coriolis team since 2011, and also related always with the development and solution for composites. The third one has been a change in the table. It was expected to be Didier Granville, is on the audience. Right now is Mr. André Bertin. He's the president of CoExpert, also provides solutions for composite solutions. Airborne is also part of the table, represented by Mr. Michael Kremers. He's Chief Technical Officer in Airborne, and he's a part of the company since 1996, and he's a member of different associations related to composites in the Netherlands. And last but not least, the KVE Composites company that is represented by Mr. Martin Bach, which is commercial manager for thermoplastic welding. So we cover a little bit all the technology that has been mentioned in the previous round, in the previous panel. I'm going to start with the first question. Also, it's a question, a two-part question. The first one is, the first thing that you do with composite is basically to lay out the material. So my first question is, directly to those guys that invest the most on laying up and the experience that you have proved over the years. Which are the key technical differences between a thermoplastic and a thermoset layup? How those differences affect in the operational requirements of the machine and this efficiency? And the second part of the question is, are you observing a growing demand of thermoplastics equipment over the past few years? Maybe Inigo start the question.
Can I start? So first of all, thanks Vidam for inviting us and doing this great event. At least till now, let's hope we keep the level of the previous panels. Answering the question, yeah, we have to say that thermoplastics and thermoset lamination is different, okay? In the end, we have the goal of applying one layer after the previous one and get them attached, okay? It's not more complicated nor easier than that. The truth is that for thermoplastic, we need melting, which is different, okay? From a physical, chemical point of view, that's different, and that's imposing different needs for the process. So we need higher temperature, we need different control of the pressure, and those generate some real different specs for the machine that are hard to accomplish, or at least they are not as mature as we have them for thermosets, okay? Another issue is the material itself, the stiffness of that material, which is different and harder to handle in a productive process, which becomes another challenge, okay? And that adding of issues generate a technology that needs to be somewhat different, okay? I would say that the lamination of thermoplastics shouldn't be that different from the lamination of thermosets compared to metal production. So we did make a big jump when we started to manufacture components in thermosets. So the manufacturing processes, the approach was totally different. And here we have an opportunity of a long-term experience that we can get benefit from that. But it's true that the condition is different, and they are implying different designs, different heating sources, different control processes, different speeds that are harder to get closer to the ones we are accustomed in lamination of thermosets. But it's true that there are options, there are opportunities that need to be evolved. And probably, and I agree with some of the previous panels, one of the things is to have some pull, a specific part, a specific program that requires the technology that is going to pull all over the supply chain, okay? To generate, to introduce the needs, the new technologies in order to do that. Because this brings me to the second question. Currently, at least from a point of view, thermoplastics equipment demand is growing, but it's true that it's still focused on research centers, R&D developments, and R&D programs, which means that the technology is still maturing. It's okay, it's totally understandable. But it's true that we are at that point, okay? We need to support those programs, and those programs, R&D programs, need to pull from the technology suppliers as well in order to make or give us I don't know, a sandbox a scenario where we can introduce these developments and mature them, as well as the global technology, global application. So when the jump is done towards a specific part manufacturing, and I'm talking about big parts that require unidirectional carbon fiber distribution, that all the supply chain is ready for that challenge. So that's my point of view.
Okay, thank you. Mael?
So from my point of view, so first of all, yes, for sure, thermoset and thermoplastic is really different material, but the machine are able to work with both material. The main difference will be on the thermoplastic, on the heating source, on how to heat the material and how to compact, how to apply pressure, and it's quite different than thermoset. But the system itself is quite similar. It's really similar. But then it depends what we are talking about. If we are talking about in situ consolidation or fast layup, and then you add another step as forming, as curing, and then there is also a difference between these two processes. But we reach quite a high level of maturity thanks to a lot of R&D projects. We started in Coryllis in 2010 to work on thermoplastic, and we work with a 13 R&D project. We are working with a lot of R&D center all around Europe and even other outside Europe. So I think, as you explained, I mean, we are in R&D mode. We are ready to jump to the other step, and we are waiting for the OEM to pull us and to bring parts to really show our capacity with this machine. And regarding industry, I come back to the thermoset material and the thermoplastic. Thermoplastic, it's a chance, I think, really, because it's I recall a kind of dead material. I will say, if you compare to thermoset, which is quite complex in terms of controlling regarding the temperature of applying this material, the variation have quite a lot of influence. And thermoplastic, I mean, the temperature of the outside room and the industrial room is not so important. So I think we really can improve manufacturing of the part and make it easier with thermoplastic than thermoset. So I'm really pushing this technology. And last point regarding the demand, I say the demand is growing since the last year. So we started in 2010, and the demand grew a lot the last year. And we sell around 30% of our machine ourselves for the thermoplastic machine. I would say more in the IT side, but yeah, I really think we can move forward on this with this technology. Yeah.
Okay, thank you. Most of you are aware, but laying up in thermoplastic gives two possible chances. One, rapid deposition solution, that is in a standard like a thermoset material layup. And the other one is in situ consolidation. I will give the word to André, because they are recently, well, they are not new to the composite technologies, but they are quite new regarding thermoplastic and in situ consolidation, and they may have an answer to the following question. From your opinion or your experience regarding the development of new equipment for in situ consolidation processes, have you developed a specific system for that purpose, or is a common system that could be from thermoset layup that could be fine-tuned and modified a little bit to be adapted to an in situ consolidation process? What has been your approach?
The approach was the same as we had for RTM SQ RTM. We're known for having built the spoiler solution. Every hour there is one air brakes in the RTM being demolded with our tool or press and everything. We developed the wing of tomorrow for the wing, for the sparring in Finam. The idea is always, and why we succeed was, what do we really need for the process? And to make a low-cost part, we need high-cost equipment. There is no low-cost equipment that make low-cost part. It was infusion, you know, it's dead. It's RTM with high cost. And so the purpose with thermoplastics, we had a project with Lockheed Martin and Syensqo on SQ RTM, and then Syensqo told us, could you work on thermoplastics? Because our US partner, Automated Dynamics, is in thermoplastics in Sever. They are no part of Trelleborg. And we said, okay, what do we need to build the right equipment? How strong should be the gantry? How quick should it go? We develop a gantry with carbon fiber reinforcements. We don't compromise on anything. We have multiple lasers. We have a lot of pyrometers, high-speed acquisition. So we develop what really we need. And still today, I question Syensqo, what is your dream? There is engineer not saying, I would like to keep the whole part at this temperature, but it's impossible. We say, no, everything is possible. Just ask. Dare to ask. Don't make supposition. You're a material expert. Don't suppose what an equipment expert can do. And then we develop an equipment. We go to 1.5 meters a second with a 1-inch white APC2 tape. We have perfect crystallinity, consolidation, ALSS. And from there today is, what can we do with that? And what is interesting in the program is we develop the same part as QRTM and in situ consolidation with the same equipment, the same deposition, the same press, the same tools. You know, we supply also no press for thermoplastic, so we can go from the fiber to the part, full equipment in thermoset or thermoplastics. So it's just, what is the actual cost? And it's great to have a program with the material supplier, the equipment supplier, and the OEM, without any politics, whatever. We have access to the whole cost of everything. And then put everything in a spreadsheet. What is the cost? What's the performance? What do we have to do to reach the material quality? And with that, we feel today we start to see where we will crack the system. And it's not thermoplastic against thermoset. It's different material, different use case. And today I even say maybe on a program, in part of the program or some phase of the same program, you could use in situ and maybe later SQRTM. So it's really bring all the mind together and look what we can do, because we need every technology to succeed. And it's what we do today with equipment.
Okay, thank you. You have experience in mTORRES with in situ consolidation. Which is your approach?
Yeah, as Fidan well knows, we've been collaborating with you in the in situ consolidation development of technologies, and it's true that from my point of view, we have focused initially on adapting the technology from thermoset to thermoplastics, which makes total sense because you need to start something. But maybe we need to push a little bit that, right? And I totally agree with Kasper. The solution should be more integrated with more points of view. And maybe we should raise some questions, for sure, some of them depending on the equipment, on the specific process and the capabilities the supplier of technology of equipment can do without supposing. But it's also true that maybe the use of thermoplastic prepregs is a good way, or there are potential other options, such as, I don't know, semi-preg materials, commingled materials, okay, that could improve the material capacities through the manufacturing process and achieve a specific performance. So it's something that should be taken into account as co-expert explained on a more holistic point of view. With that, we can generate a new technology that probably would have extremely adjusted cost, although it would be pretty expensive, as we talk with Aciturri. But sure, we have a lot of room for improvement, but we need to find, and I totally agree, the specific process, material, and part, and with that combination, generate the most optimum approach.
Okay, thank you. We have been talking basically is the layout of unidirectional material. I will go with Marcus probably, because they have experience in other solutions to lay up different combinations, different materials. So which other ways could we automate thermoplastics from your point of view?
Yeah, thank you. And also thank you for standing up, because I was afraid I need to sit on the,
No problem.
on the table.
My pleasure.
No, so we have a little bit different view. So AFP is great, and UD tapes are great technology. We started with looking to the press, because in thermoplastics, it was mentioned before, also by Arnova, I think, press makes a lot of sense to make a thermoplastic part. That's the beauty of the material. And then you need something in front of the press to make a tailor blank. And customers don't want to have a constant thickness blank. You want to have a tailor to thickness variations, typically also combinations of materials, carbon and glass, lightning strike protection. Maybe sandwich materials are also now being developed in thermoplastics. So you see a whole range of materials being looked at. Semi-preg is also interesting, because you can use the press not only for forming into 3D shape, but also for impregnation. So it's a little bit like in thermoset materials, where you have pre-preg or you have dry fiber in RTM. In RTM, you do the infusion in the press or in the tool. And you can do the same with semi-preg materials. And semi-pregs are easier to handle for our machines, at least. So what we make is automated ply placement machines. So it's pick and place based. The materials are being cut on a cutter, and then with pick and place we create a laminate. And we are also developing what we call semi-consolidation to make sure the laminates are good enough to go directly into a press. And that's basically a point of taking the air out of the laminate once you have done the spot welding. So in our mind, if you have a press and then before a process to create tailor blanks, you separate the two processes and you get a more lean process, also capable for high rate manufacturing. And you provide the designer more freedom to design the part with more options. And also productivity can go up because with our process, we can handle wide material rolls, just as what you have in thermoset. You have 1200 millimeter rolls, ideally, also in thermoplastic materials. Not always they are on the market, but it would be great if it's wider, because then the material costs can go down, because for material suppliers, it's more efficient to manufacture the materials. You avoid the slitting. Slitting is also a cost. And we can handle big plies, because we can cut large shapes. So ideally, if you have a layer in a part, then the ideal is to have just one ply, because you then also get rid of all the gaps and overlaps. So productivity goes up, there's more freedom for the designer, and also the processes become more robust. And as you said in your introduction, to create high rate, I think robustness is very important. So in our mind, it's good to separate the steps and have a bit different approach than AFP. Of course, presses have a certain size, so if you go large, yeah, then you need probably AFP. But if you go medium size, then press and pick and place before could be a good option.
Thank you. So you say that your technology is ready to use.
It's ready to use. We supply automated ply placement systems for pre-preg, so pre-preg and dry fiber and thermosets, and we can use the same in thermoplastics. There are some differences. For us, for example, it's important that the materials, once we cut them, don't have too much residual stress. So we design our machines to be able to cope with plies that are, let's say, deforming. But that's an aspect to take in mind. And therefore, semi-pregs, again, are for us easier because you don't have so much residual stress in the material.
Okay, thank you. Well, as has been mentioned in the panel before, muscle foil by Arnova probably was mentioned specifically. Welding is the key technology for thermoplastic, probably. The fact that we can avoid the use of mechanical fastening and all the operations related to that is something that is a very key point of the development of thermoplastics. And we have the luck to have you here because you have one of those systems that are already used in some parts that are flying. From your perspective, is welding technology ready for widespread application in aerospace? What do you think is needed to fully unlock the potential of welding? Because we know that you use it in fabrics, for instance, but unidirectional tapes are kind of a challenge.
Yeah. So indeed, first of all, I have the feeling all eyes are on us with the welding technologies. Yeah. So I think to start with, it's important to understand that the technology we have in KV is already flying and qualified using fabrics. So it is proven to be able to get it qualified. But what you see with those cases, it is a qualification on product level. So our customers who use the KV technology, like GKN, like Salvador explained today, they use our technology on their license and they have developed the technology to work for a specific product. So there's now 3 applications of our technology successfully flying for almost a decade. But what we see as a challenge at the moment is not to have a qualification on product level, but on process level. And that requires a much deeper understanding in a wider element of the industry. So what we are doing at the moment within our group, because KV is part of Daher, we are qualifying the technology also for UD-based materials. So we can say it's TRL 9 for fabrics, and internally we are now close to TRL 6. But we have defined a use case where we can test this. It is more difficult with induction welding to weld UD-based materials because it's more the fibers are very sensitive to the magnetic field, so you see more variations. But what we are doing now is that we understand better the materials, and in the end, the equipment itself is not different. It's really how does the material respond and how to define the right settings. But if we look at the wider element of the industry, like we are doing the work now, for example, with Airbus, we're doing a TRL3 qualification, but there you need to, after TRL3, look for a use case. So we need to work together as an industry to define which technologies fit on which products. It's not the case that every technology is the best for each application. Like our technology is really strong to make a closed box assembly, for example, or more complex structures with thickness variations. Some are better for welding stringers onto skins. But where it starts is the certification of the technology and following the pyramidal approach. So what is for sure very important is to have the FAA involved and EASA to define certification standards for these welding technologies. Because in, let's say, so far, it's often seen as a different way of bonding. But it's not bonding. You're not bringing an additional layer between two parts. You're doing polymer fusion. So we know now that FAA is evaluating it as a co-consolidation process, so local consolidation of the technology. So that's something where we need to take a step. So it needs to be better understood by the design authorities to get the technology approved. And second to that, if we look at our process for UD welding, we need to have more process control. So more robust response of the material and allow the equipment to respond to how the material is reacting. So this is something we are working on. I come back to that in the last question. But it's a key thing. And one of the other elements we see in the market, it's repair of composite structure. So it was mentioned already that maintenance is a key thing for the success of thermoplastics, but repair as well. So we get some questions from our customers like, is this technology also able to be used as a repair method, or how can you repair welded structures? It's a very important element for the final application, because you can weld a structure, but once it's there, how do we do an in-service repair? So this is something which is still being researched. So we know there are some research institutes looking at this topic, but there are no qualified solutions yet. So that's one of the key elements which need to be put in place. And I think finally, you see that the welding technologies, they are often being researched at research institutes and within some companies who do their own development of welding technology, like Collins, for example. So they focus on applying welding internally within the group to bring it for a specific application. But I think as a market, we need more companies like KVE who supply welding technology and have a mature industrial supply chain there as well. So once the technologies are qualified, equipment can also be qualified, and then it can be used by a wider range of customers. And I think that's a key element we need to work on together as an ecosystem.
Thank you. Very nice. That comes to my mind. The third element has been constantly repeating today. There is cooperation between all different agents, from certification, from authorities, and also material suppliers and equipment suppliers. Well, I have one more question, but still checking if you are dead or not. Anyone has a question for our guest? Thank you, Begoña. You can pass a microphone.
Hello? Yes. So thank you for your inputs. Maybe the fifth key question is, key aspect is the digitalization, how this can improve in these thermoplastic processes.
It's open questions to anybody, or all of you.
From Collis' side, for example, we are working on the simulating the heating distribution. So to improve the quality of the part at the end, to be sure that the material will be well heated. So we are working a lot on simulated and the digitalization of all the heating distribution on the part.
Yeah, there's data acquisition, of course, important. We also look a lot to what's happening before you start running the machine. Because if you do pick and place, there are many different ply shapes, many different movements. You also need to have recovery scenarios. What if one ply is wrong and you need to recut it? So nesting needs to be adapted. So we put a lot of effort in software that makes the robot think for itself. So there are recipes, there's part design, and then all the robot programming is done on the fly so that the machine can become adaptive. So that's a very important part. So it's software, it's digital, to make this technology work.
Andre?
You know, I don't know if it was, yeah, on our process, we have server in production sucking data from thousands of RTM parts. Data is key of composites. Without data, you have nothing. And we do the same with in-situ consolidation, with fiber placement, is suck the data and then feed the simulation, develop simulation of the process. So we are in an approach where we have the data, sensors, advanced sensors, feed the simulation, have test bench of elementary part. We develop a test bench with a laser, a pulse light, just to understand the heating transfer in composite, go to the basics and learn the data. And this is really what we need now in the industry, is what everybody is moving. Digitalization is key.
Inigo?
From our side, we've been strongly working and investing on digitalization technologies for the lamination processes that applies as well to thermoplastics. Okay, so it's critical aspect to have this data. Not only, and for sure, it's important to have the simulation of your process to get the better approach, to introduce new technologies such as, I don't know, distributed laser heating for the thermoplastics so you can better control all of your process. But it's also important to have information during the process. And that's a critical challenge as well, to have an online system that can provide information. And I would say that, and here for Begoña, for the research center we have, at least from my point of view, there's still a gap where it would be interesting to work, which is the quality of the interface between two layers. So the previous layer you have and the layer you have just laminated, how can you measure that quality before finishing the complete part and have your NDA inspection? So.
Thank you. Martin, please.
Yes, I think what is really relevant to understand is the discussion I just explained about welding UD material, that the welding process of induction welding is more sensitive to this kind of materials. But in order for us to measure the actually interface temperature, nowadays we use thermocouples. But in your flying part, you don't want to have thermocouples. So we need to have some kind of reference information with non-invasive sensors to correlate the weld line temperature with other locations around the weld. But we use an assembly jig for the welding process. So it is basically pressurized and within a rigid frame. So it's not very easy to access that. But what we're doing now is finding non-invasive sensors to correlate that and use machine learning to see how the material itself is responding to the magnetic field and then adapting that. So it's for us really one of the key elements as well for the certification of the process, to know that by having this reference data, we will be in the processing window. And finally, of course, there will be NDI methods to do a correlation between the weld width and what has been achieved, but to avoid to have direct measurement systems inside of the weld line. So for us, it's really a key thing we are working on at the moment.
Any other question?
Yes, thank you. Malte Fröfel from INTA Research Institution. What is the future material? PPS, PIKE, PEEK? Is there anything?
I won't let you answer these questions because this is a panel afterwards just related to materials.
Okay,
Well,
great.
If you want, do it yourself, and then we check with the other panel.
I have no response. So
Yeah.
just
Yeah. Anyone?
Well, I think it's difficult to predict the one future material. I think as equipment suppliers, you want to be able to process, let's say, a portfolio of materials, because depending on the part was mentioned before, probably one material is better than the other, also depending on the process. So like in thermoset materials, there's not just one material, there's a whole range. I think thermoplastics will also develop in this direction.
In the case of in situ consolidation or maybe welding, there is some insight.
In the end, we can adapt our equipment to specific materials. If it's PPS, if it's PEEK, okay, it's a matter of finding the adequate heating source. It's a matter of finding the adequate materials for the components to get in touch. But it shouldn't be our key worry, I would say, as equipment manufacturers, if the material is of thermoplastic nature. Okay, if we modify that and go a different material, which is not thermoset thermoplastic, but a different approach, that would probably will need to make our gears start running to find a new solution. But if it's a thermoplastic, I would say the baselines are ready, but we need to continue evolving.
You want to say something, Andre?
Yeah, I think you speak about qualification material. The point is, okay, the TRL, the material, the qualification, I think today the big challenge is the manufacturing readiness level. For that, we need enough equipment supplier. We need to be able to deliver the material in such quantity for ramp up of a program. So today the big challenge in Europe is mostly the manufacturing readiness level. There is not enough equipment supplier on the market to deliver equipment for the next generation aircraft. There is not enough mold suppliers. So the challenge in Europe, we have to really look at TRL, all the innovation, but sometimes we are very weak with manufacturing readiness levels and being ready to deploy in big quantity. So material is the same problem. What's the quantity can be delivered with qualification, with repeatability and everything?
Thank you. Martin, do you want to add something?
Yes, of course. So for the welding technology, we aim to be able to weld all reference materials in the aerospace used. So of course the flying applications have PPS, but we now weld LMPAEK, PEEK, etc. As long as it has carbon fibers, fundamentally our process works. And of course we need a polymer matrix. One of the challenges we do see is that with the higher temperature systems, which you need to weld between 380 and 400 degrees, also the tooling around the part is reaching some of the limits. Because we cannot use metals too close to the weld interface because they will also work with the magnetic field. So we need some other type of materials. And if you talk about silicon to pressurize the part, there we see some limits, but at the moment we are able to weld basically the range up to PEEK. So for us, it's not really in that sense a challenge in terms of the process itself. It's really to understand, is the material itself also how it's been delivered? Is it also a repeatable quality? Okay. Because in the end, welding is the final assembly step, so it is dependent on the part quality. The part quality is dependent on the material quality, etc. So it's where everything comes together. That's something we need to understand as an ecosystem as well. That in order for welding to work, the elementary parts need a certain quality level.
Well, thank you very much for your inputs, and thank you very much for your questions. I think this panel is running out of time, so thank you very much for everything, everybody. So